Yeah.
You gotta think you go. I'm not worried.
Yeah, like, it was like 7. I gave 6.
Nah, bro, you're one. If you hadn't said that, I probably would have. I can't now. That's all disrespect.
I not, yes, you can, we can show me on nights, but just any.
Okay, yeah.
Yeah.
Okay.
So, this is what I would like for us to do, this week. And also give an idea what we're gonna do next week. So, I like to just be able to kind of pace us through our, packets 5 and 6. So this week, if we just focus on the FRQs, which are packet 5. So I'm gonna pick out problems from 2023 FRQs today. And then, this is kind of like a rough estimate, but, the idea is that if you can follow the schedule, then you can finish both these packets before the AP exam, and then that will be ideal because then you would have seen as many types of problems as possible before your AP exam. But you won't get penalized if you turn in or if you finish your packet after the AP exam, because I just need you to show me both these packets completed so you can get your quiz grades. Tomorrow we can work on 2022 FRQs. Then 2021, and then I'll pick out 2018, 2019 Thursday, and then Friday I'll pick out 2016, 2017 FRQs. Next week, I may try to finish up a little bit more on AV FRQs, depending on if I feel like that we should see some additional FRQs, or if you want me to go over additional FRQs, we can. But next week, I think students will be even more in and out because of AP exams beginning. So we're going to follow this rough schedule here. Thank you. And then I'll try to pick out problems from packet 6 for page 1 to 15. And then you guys can also work at your own pace if you've already done some problems. So this is our pacing schedule for these next 2 weeks. But you can turn in your packet 5 and 6 anytime. But I know seniors' last day is next Friday, so if you want to get it in to me by then, you can, or you can wait until after the AP exams and come by and show me. I can just flip through and I can just mark you down for your grade. Any questions with our schedule for this week and next? Okay, I'm also working on trying to finish up grading your FRQs. And your multiple choice tests, so I can return them to you, and I'll also attach the keys so that you can know what you missed and use that to help you prepare for your AP exam. I do just want to kind of briefly go over some of FRQ predictions for this year, and these predictions are just really based off of what we've seen. Over the years and just some of the patterns that we've seen. And, it's not always going to follow this, but I think this kind of gives us a good idea as to what our FRQ experience will be like. So you're going to start off with 2 calculator questions. Rate in, rate out has shown up a lot on calculator sections. And then Riemann sums, I'm just guessing that maybe that's the FRQ. And then within rate in, rate out, you have that total equals initial plus amount added minus amount removed. We'll see some of that over the course of this week. Riemann sums, typically that's where you're going to see your particle motion, you're going to see your MPT, you're going to see final equals initial plus displacement. That tends to show up a lot with particle motion. Now, not every Riemann sums is going to be particle motion, but just wanted to show some of the patterns. And then for 3 through 6, those are non-calculator FRQ. So a derivative graph, that's pretty common. That shows up where you're going to have to interpret an F prime graph. So there may ask you for relative max, relative min, concavity, extreme value theorem, second theorem tends to show up there as well. Solving differential equations, sometimes related rates tend to not be its own FRQ anymore. They tend to insert related rates into like a part B or part C, like a subsection within the FRQ problem. And sometimes it may show up in any random space, but sometimes it shows up under differential equations. Function table values where they give you information about a function in a table, and they may ask you to find the derivative. And a lot of times, like chain rule, product rule, implicit, first theorem, use substitution tends to show up. And then number 6, area volume tends to be where this lives. So this method, washer method, cross section, use sum. But sometimes area volume can show up in the calculator section as well. But if it's non-calculator, then they're usually just going to ask you for the setup. But if they ask you to solve everything all the way, it's usually it's got to be something easy enough where you can do it by hand. It won't be a messy problem with really difficult use substitution. It should be if it's use substitution, it's going to be pretty manageable working through. Right, so hopefully that kind of gives you an idea. As we go through these FRQs, you're going to begin to see these types of problems show up again and again, and this is kind of like a guide as to what could happen for your AP exam students. Right, so let's start with number 1. Oh, and also I made I didn't put a key version for packet 5 in your packet. I have a class copy here though, so you're welcome to come up and grab a class copy if you want to just, if you're working ahead of me or if you're working on a different problem, just to have a key on your desk. But if you take a copy, make sure you return it at the end of class. I only made enough for a class copy so that all the classes can share this. But then when you're at home and you want to work on this at home, I have the key available, both packets 5 and 6 at the top of my spring review page. So just go to that page and you can access that key as you work through the packets. All right, so you can go up and grab one if you'd like to have a key as you're working. Okay. But we're going to start with number 1. Any questions? Yes. I think you said I'm sorry, can you do that? And go into yeah, I had to say that. It's funny. No, I was not listening. You hear this guy? No, you guys picked up packet 6 a while ago. Is anyone missing packet 6 that they need? Okay. Let me know after class if for some reason you realize you don't have packet 6 and you need to pick up packet 6. Okay. 11 and 12. I think. Okay, so let me read through number 1 and then have you guys try it. So number 1, this is FRQ for 2023. This is calculator active. A customer at a gas station is pumping gas into a gas tank. The rate of flow of gasoline is modeled by a differential function where FT is measured in gallons per second. Using correct units, interpret the meaning of the depth integral. Use the right Riemann sum. So they're telling you which intervals to use. So they're going to just do rectangles. So find your width, find your height. And it says interpret using correct units, interpret the meaning. So you know that if you're going through integral, your units will change, right? So when you explain the meaning of this problem, you're not going to use gallons per second, right? Because that's f of t. You know the integral of t is going to change that unit. So make the appropriate change. All right, so try part A. And I'll go through in a minute once you guys have a chance to try it.
Part B, must there exist a value such that f prime of c is equal to 0? So anytime the problem is asking you to guarantee a value, typically it's IVT or MVT. It could be an intermediate value theorem, or it could be a mean value theorem. And this intermediate value theorem, those are easier to spot. You're just looking for a value that you can guarantee because you have a value above and below your target. That's the easier one to spot. But if you can't spot that relationship, then you got to rely on MVT. MVT or roles is where you have a table of values, but you're asked to guarantee a slope of that of that level. So in this case, looks like we're gonna have to maybe rely on MVT because we're asked to guarantee an f prime, but we only have f table available to us. So can we show that through our table that there's going to be a slope 0 somewhere? And slope 0 can exist. This is between 60 and 120. So slope 0 can exist if your y values are the same. So if my y values are the same, that means my graph is going to have to go up and come down, or go down and come up in order to hit those two y values, and that can guarantee a slope 0. So that's our strategy there for part B. Mean value theorem requires statements about continuity and differentiability. And because we're trying to guarantee a slope 0, you can either reference this as Rolle's theorem or mean value theorem. Either is fine. Because mean value theorem is just a very specific version of Rolle's theorem. Sorry, Rolle's theorem is a very specific version of mean value theorem. Part C, it's asking, can we find the average rate of flow of gasoline? We have something at the gasoline in gallons per second. So we just need to find the average value. So that should hint at you to use average value theorem. So we just set it up. As long as we know our formula, the rest can go in our calculator. And our units, our measure will still remain as gallons per second. So some students have asked, wait, we're taking the integral of f of x, so shouldn't the gallons per second change? It technically does. So we know that f of x is, g is in terms of gallons per second. And so the integral of from 0 to 150 will take it up to gallons, but then we're dividing by time. So we're back to gallons per second. So this process will just bring us back to our starting units, even though there's an integral here. Part D is asking for G prime. You know G is already at the gallons per second level. So G prime will take it another derivative down, which is basically second derivative because gallons per second squared. And we need to be able to talk about second derivative in these words. rate is decreasing or rate is increasing. We want to use those phrases to ensure that we get the graders to give us the points that we want to earn. So don't use the word acceleration. Don't say rate of a rate. That's not clear enough. Look at the sign of your second derivative. If it's negative, then say something about how the rate is decreasing. If it's positive, then say something about how the rate is increasing. If we can skip 2, I think 2 is an easier problem. I prefer to save the easier problem for you to try at home, and I want to just do the ones that that may be a bit more challenging. So we can go to number 3 once you guys are done with 1. Problem number 3, page C. So we're looking at number 3 here. This is a non-calculator question. So part A, you're just going to build a slope field based off of your diagram. So just follow the path of your graph. Part B is where you're going to build your tangent line. So get your order pair, get your slope, point slope form, and then do linear approximation after that. So again, we're skipping number 2 and going to number 3.
Will it always just be one quadrant on the slope?
Oh, for the slope field?
Yeah.
It depends. It may span across a different quadrants, but you're just kind of following the flow of the graph, wherever the graph leads you.
So it wouldn't be 2 different quadrants that had like a vertical or a horizontal axis to
If it did, then let's say it gave you all 4 quadrants, and there was a horizontal asymptote here. Then you will just kind of follow the flow of the graph and just yeah. Wherever the slope field is leading you, you're just kind of following this.
But you only do one.
You only do one because right. We don't want to do one over here because we want one that's going to go through the point that they're asking us to go through. So it says we want it to go through 0, 5. So if we want to go through 0, 5, then it's going to be have to go through this point here. So we want this slope field and not this one. So the top one here wouldn't go through the point that we want. For part B, you want to build your tangent line equation. If it helps, if you want to start off writing your tangent line equation with a form that you're more familiar with, and then from there you can build off the one that you're going to be using. So replace x with t, replace y with m, and then you can just build it the same way that you build with a tangent line from your original variables. So your order pair is no longer xy, it's t comma m, and then your dm dt is your slope. Part C is asking you to do second derivative. Well, we already have dm dt, so we're going to have to get to d2m over dt2. Notice that time is involved here, so there's a little bit of kind of related rates going on. M is going to get impacted by time, so m's derivative will become dm dt. So I just first distribute the 1/4 through to get my constants and my variables showing, or to get my individual terms set up. dm dt becomes d2m over dt2. 1/4 times 40 will go to 0, and then 1/4 will stay at 1/4, and m will go to dm dt. Once I have my second derivative, I'm going to replace the dm dt back with in terms of m, so that it makes it a little bit easier for me to interpret. I know this is the moment in time when m is 5, so if I plug 5 in for m, I really don't care what number I get. The important thing is that the second derivative value is negative. If I have a negative second derivative, I know my graph is concave down. If my graph is concave down, then any linear approximation is going to be an overestimation. If my second derivative is positive, then concave up, I must be dealing with a under approximation. But in this case, a negative would indicate concave down, and this approximation is going to be an overestimation. Sorry, let me go back. I didn't mean to jump to that. And then part D is where we're going to do our full separation of variables. We're going to solve our differential equations. So we want our cross multiply, t's on the right, m's on the left. And we'll just end class with part D. Here's our steps for separating our variables. So I first wrote them as separate fractions, then cross multiply. As you cross multiply, you should be able to see some things that's out of place. You want all your m's together on the left, and then that 4, you want to just go ahead and move that over to the right side, so that we can kind of keep that left side as bare and minimal as possible. Left side, a little bit of u substitution, but it'll end up being 1 over u du.
And the right side is power rule, the 1 will turn into T. Once you're here, you're done with the calculus. Now you're trying to solve for C and solve it for M. I distribute the negative through, raise both sides, E is the base. I solve for M first, and then I solve for C, and then I put it all together at the end. So your goal is to just kind of chip away at 2023 FRQs. It'd be great if you can get through all of 2023 FRQs. But if you don't, then even if you do 1 or 2, you're making progress, and it'll be good for us as you prepare. Right, just get your phones, and if you borrowed a packet from me, just return it, and you'll pick it up again tomorrow.
Why do you propose?
It just makes it a little bit easier for me to plug something in. So I replaced the FRQ with that. So I can just have, I know that I want this is the moment in time with let's say with 5. So I want to do this with 5, and this feels a little bit harder to make them total. But this is the same thing. The DMPT is equal to I just made that substitution so I can actually plug in. Right. Right. Plug in 5 in there. Oh, negative. Good. Positive.
Thank you. Draw it to like it'll be like I never. If I use it.